Hello.
Yes, sir, we are able to hear you.
I am audible.
Yes, sir.
You make.
Yes, sir.
Okay. So please note down the instructions. First of all, you use headphones. Second is that you, if you have any question, you just chat with me. Then please switch off mic once we start the lecture. And after the completion of this particular lecture, please give me feedback here itself as well as on your WhatsApp group, right? So that if there are any lacunas, we may be able to overcome that, right? So straightway we will like to start the Pedkar sir. Hello,
Yes, sir.
sir. I am starting now.
Yeah. Okay.
Okay,
Audio
sir.
is clear. Video is clear.
Okay. Okay. Thank you. So good afternoon, everyone.
Good afternoon.
I have told you to go through the instructions which I have given you in the first slide. Once again, I am repeating that you have to use the headphones only. You have to use chat feature for asking any doubts or question. Then switch off your mic and please give me your feedback here as well as on your WhatsApp group. Right? This is my request to all the participants. Now, today we start the lecture on models. We also call it as waiting line theory. So basically, we will like to see the basics of queuing models or waiting line theory. Most important thing is why we first important thing is that why we go for queuing models or what is the need of learning queuing models. In our day-to-day life, there are various examples. Specifically in India, we have seen that uh, every time, every time, everywhere, you have to face queue. Queue is a part and parcel of Indian culture. It's everywhere in the world, but because of a huge population, we can say that in India we have to face queue everywhere, almost everywhere. Now, why why we need to focus on this aspect? Because queue is a whenever we need to spend our valuable time and that costs something. So cost is directly related with the queuing system, and for that purpose, AK Erlang in 1903 has developed a queuing model or waiting line model, and he started developing this particular model uh, because of the congestion on traffic that time. You can imagine that in 1903 also there was a congestion of telephonic traffic, and for that AK Airlines has given uh, queuing model to us. Again, I am this one more thing I am interrupting here. Participants, please switch off your mic. Please switch off the mic. It is really disturbing. So next, what is queue? Queue is basically a flow of customers, right? A flow of customers. When a flow of customers comes to a service facility. Now, these are the two major important aspects: the customer and service facility. Customer means, customer means population, people, machine, material, everything which need a facility, which needs some treatment, which needs some process. They are customers. We also call them as arrivals. We call them as arrival. Secondly, these customers they are getting some sort of service, and the service is given by an entity called as facility or facilitator, or we call it as a server. And whenever there is an imbalance between the incoming or arrivals and servers, there is a formation of queue. If the number of customers exceeds the capacity of the server, there is a formation of queue. In that case, we can say that the customers are in the queue, they wait for the service facility and hence they are in the queue. But sometimes, because of the less number of customers, and if the capability or capacity of the service facility is more, in that case, the service facility remains idle, so it also forms a queue. So queue is for both the customers as well as the service facility. And hence, we can say that waiting line problem arises mainly because of too much demand. That is the case when the customers are more, excess waiting time is there, then in that case, queue is formed, and it is only because of over demand. Second, when the number of customers are less, when the number of customers are less, participants please switch off the microphone. There is a huge loud noise here. Please switch off the microphone once again. So waiting line problems, they arise because of too much demand or too less demand. So too less demand happens only when the customers are less and facility are more, and in that case we can say that facility servers, they are in idle state. So in this context, we can say that a queuing system is one which consists of customers, servers, and because of the imbalance of the arrivals and the servers, there is a chance of formation of queue, and hence the queuing model consists of customers, servers, and queue. We have seen this particular aspect that there are so many occasions where we face queue in our day-to-day life. These includes restaurants, departmental stores, cinema halls, banks, post offices, petrol pumps, airline and railway reservation counters, hospitals, manufacturing units, and so many examples are there where there is a formation of queue. In engineering, considering the engineering aspects, the problem of formation of queue may arise when some machine breakdowns or it needs repairs or some proper scheduling is not done or there are scarce of material or production control is not proper, or in all the minimization or optimization is not there between the demand and the server, between the arrival and the server, then and then the formation of queue is there. And in all these conditions, or we can say that all these examples, the queuing models can be applied over here only. Now, as discussed earlier, the constituents of queuing system, the main or the major elements of queuing system, it includes the customer, queue, and service channel. As explained, customer is nothing but any arriving units in the system is a customer. A machine may be arriving unit, it is a customer. Any vehicle, anything which arrives in the system is a customer. And service channels are those which are the facilitators, the servers, all those are are included as a service channel. Now, in this case, broadly, service channels, they can be a single service channel. For example, if you consider hospitals or a single doctor working at his own place, it is also a hospital, clinic, we can say that. So this clinic and hospital, we can say that hospitals, they are multi-server units, whereas doctor who is alone working in his clinic is a single server unit. So every queuing system, it may be a single server unit or it may be a multiple server unit. Secondly, in a particular system, a customer, only single customer may enter or large number of customers may enter. So accordingly, we we consider the arriving units as population as finite population or infinite population. Finite population means a limited number of people or limited number of entities when they arrive in a particular system, we call it as a finite population or finite arrivals or finite customers. Whereas if you consider servers as discussed earlier, server may be one, it may be more than that. So someone is using it is so it may be one or it may be more than one. So accordingly, we call it as a single server unit or multiple server unit. So broadly, we can say that service system, it consists of arrivals, the servers, and the queue. Input source is always the customer, and output source is also a customer, but he gets some service, and hence the output is served customers, right? Then Q, the number of units. Now, one more thing, that's in every service system, every queuing system, it's broadly consists of two more important parameters. Number one, it is a it is a queue. That means the exact number of units or the exact number of arrivals which are waiting for the system to serve, and the other one is the service mechanism which is working. The service, for example, consider the case of doctor, for example, who is sitting who is sitting in his cabin, and some customers or patients, they are arriving there, they are sitting in the lounge, right? Now imagine that the first customer is entering into the cabin of that particular doctor, and that particular customer, he is getting the service of that doctor, he is getting the service of that doctor, he is treating that particular patient. So he will consume some time for treating that particular patient. He will check that patient, he will try to diagnose the disease or whatever it may be. So it will consume some time, right? That is called as service time. The moment doctor and customer, the patient, when they satisfy, the customer will leave the cabin. That total time is a service time. During this process, what happens when the first customer was in the cabin, there is a possibility that many patients, they may be waiting for their turn. So total system time is generally equal to queuing time, that is the patient who is giving time in the queue plus the patient who is giving time to the doctor for getting the service. So total service or queuing system time is equals to patient working in the queue plus patient getting the service. That total time is a queuing or system time. Actually, queuing time and system time, they are different. Queuing time is the time for which the customer waits, and system time is the time for which customer waits plus service time of the customer. Now, these are the most important uh, terms which are related with the queuing models. Let me tell you that these basic concepts are important. The numericals based on this topic, they are very simple. But first thing is to understand what the queuing model is. So the first thing, single server model. I have already explained you what is single server model. In every queuing system, we are having some facilitators, servers, or some mechanism which serves the customer. So if it is single, like the case which we have discussed, that a doctor who is sitting in a particular um, clinic is only one, that's why we call it a single server model. Now imagine that multiple server model. The best example that I can cite is a reservation center, railway reservation center, or airline reservation center, where you can see that the type of service that you are getting is same. That is, you are doing reservation. But if the number of windows which are available at that particular reservation center, they are more than one, we say that n is greater than one, we call it as a multiple server model. So queuing system, they are classified as single server model, where the server is only one, and multiple server model, where the number of servers, they are greater than one. Second important thing, finite queue length and infinite queue length. Again, for elaborating this, I will like to cite the example of a doctor who is sitting in his clinic. Now, imagine that the doctor is sitting in the clinic and he has decided that during his 8 hours sitting, he will check or will provide service only to 20 number of patients, right? If he decides that he will attend only 20 number of patients, that means the queue length is finite. Queue length is finite and it is equals to 20. But imagine the second case. The doctor is sitting in his clinic, but he has not figured any exact number. He will sit in the cabin and he will go on serving the patients till they arrive at his center, at his clinic. This is called as infinite queue length, where the number of patients are not decided. Right? It is called as infinite queue length, and it is the difference between a finite queue length and infinite queue length. And exactly it is applicable to finite population model and infinite population model. If you select a finite queue length, if the doctor select a finite queue length option, his population becomes finite, and model is called as finite population model. Whereas if the doctor do not consider any constraint, he take n equals to infinite number of customers, his model becomes infinite population model. So these are the 6 basic terms which are related with the queuing models. One has to understand what is single server model, multiple server model, finite queue length, infinite queue length, finite population model, and infinite population model. I hope that it must be clear to you. Next. Now the most important factor is lambda by mu. Lambda by mu. If lambda by mu is less than 1 and if lambda by mu is greater than 1, what happens? Let us see. The ratio of this lambda by mu, that means the total number of, lambda means total number of arrivals in the system, that is denoted by lambda. It is actually the rate at which the customers are entering into the system, that is lambda. And second is mu. Mu is nothing but the rate at which the service is given to the customer, that is mu. So this difference, this ratio of lambda by mu, that is mean arrival rate to the mean service rate, is called as rho. We call it as traffic intensity. And traffic intensity is basically a measure. It is a basically measure of any QM, that is queuing model. So lambda by mu, what happens when lambda by mu is less than 1 and if it is greater than 1? So if traffic intensity, that is the ratio of mean arrival rate to mean service rate, is less than 1, in that case you will see that this lambda will be greater. It will be greater than mu. Exactly reverse. Lambda will be less than mu and hence it will be less than 1. So if arrival rate is less than the service rate, what will happen? The system will get more time. and it is quite possible that each and every entity, each and every customer, each and every arrival entering into that particular system will be served. So if traffic intensity is less than 1, every customer, every arrival will be served. Whereas if lambda by mu is greater than 1, that means when lambda is greater than mu, that means when the arrivals are mu, more than mu, there is a chance that many of the customers may not be served. And in the second case, that is when lambda by mu is greater than 1, there is every chance to form a queue. Queue will always form if lambda by mu is greater than 1. But in the first case, there is a chance that if lambda by mu is less than 1, still there is a chance that there will be a formation of queue. How? For example, imagine that if lambda is equals to 5 and mu is equals to 6, right? That means it is less than 1. So second possibilities are also there. If lambda is equals to 3 and mu is equals to 4, right? And imagine that all five, they came at the same time. So what will happen? Out of these 5, only 4 will be served. So again, there is a chance of formation of queue, but it will be for limited period. Beyond that, they will be served and there will not be a queue. That is also possible. So this is regarding the traffic intensity. The next one is the elements of queuing system. Now the basic elements of queuing system. As discussed earlier, I have already told you the queuing system. We'll see in detail what the input or arrival pattern is. Arrivals, they are basically defined as the way in which the customer arrives and joins the system. Arrivals are all those things, all those entities, all those customers, all those patients which comes into the system. They are the arrivals. The way in which this customer arrives and joins the system, the arrival pattern may be random. Most of the time, the arrival pattern is random. It is not necessary that to a doctor's clinic that one patient will come in 1 hour only. It is quite possible that 10 patients, they may come in the first hour and in the last hour there will not be any patient. So the arrival pattern, there is a chance that it is always in fact random. And exact prediction of these arrivals in random system is not possible. Therefore, the number of arrivals per unit time, it is estimated by Gaussian's distribution. Now, in this case, there is this particular queuing model. It is not basically a deterministic type of.
हो माहित आहे मला अर्धा तासानंतर काय ते पाहायचं आहे किती वेळ चालतं ते पाहायचं आहे
So basically, this particular queuing model, it is not a deterministic model, but in fact, it follows some distributions. It follows some distributions. Therefore, the number of arrivals per unit time, it is estimated by some distribution. It is the Poisson distribution, Poisson's distribution. It is given. Again, someone has started the mic. The mean arrival rate is denoted by lambda. It tells us the rate at which the arrivals enter into the system. Second one is the service mechanism. The arrangement of service facility to serve customer. If there is an infinite number of servers, then all the customers are served instantaneously. I have already explained you that. So there will be no queue. But for finite servers, customers are served according to a specific time with service time as a constant or random variable and hence follows negative exponential distribution. The mean service rate is denoted by mu, and this mean service rate uh, it is nothing but the rate at which the customers are being served. That is mu. Then the another important element of queuing system is the queue discipline. Now we know very well that every queue it follows some rules and regulations. So there are basically four major rules by which a queuing system is formed. The first rule, a natural rule, is first come, first served. So when there is a queue, naturally what happens? Those who enter the system first, they get service first. So we call it as first come, first served type of discipline. Second, first in, first out. The other name. The one who enters the system earlier, he will get the service first. Right? That is first in, first out. The same, literally same. Like first come, first served. Last in, first out. This is only for VIPs. Most of the time we see that. But actually, you cannot say it is a discipline. It is actually indiscipline, but we people tolerate it. But and that's why it becomes a rule. So last in, first out. Sometimes, for example, you are in the Tirupati Mandir and imagine that you are in the queue, long queue is there, and imagine that some particular VIP is entering in the queue, and we don't know where he is, but even if he is the last person, he get the service first. That is called as last in, first out type of queue discipline. And the last one is service in random order, that is called as zero. Here in this case, generally or normally this particular type of queue discipline is considered when we do some sampling things. Right? When we do some sampling things, we use service in random order. That is called as zero. Now, in the queue system, every entrant, every customer is having different behavior. And broadly, the behavior of a customer, they are broadly classified as bulking, priorities, and jockeying. Now, for that, the best thing is that I will cite the example of a reservation counter. Imagine that we are at railway reservation counter, and it has got 50 windows, and all the 15 windows they are ready for giving the reservations, ready for certain. Now, bulking, it is basically a case where a customer leaves the queue. And why he leaves the queue? Because all these 50 queues, they are long and there is absolutely no space. And because of that, this particular customer who is the last entrant, he do not find sufficient space as well as chance of getting the service, and hence he leaves the system. That is called as bulking. So bulking broadly, we can say that it's a particular term which is used in QM where where the customer leave the system only because he do not get sufficient space in the system. Another term is reneging. This happens when a waiting customer leaves the queue due to impatience. Here what happens, though there are 50 railway reservation counters, everybody is there. This last person is also entering into the one of the 50 queues. He has got the waiting space, but because of some reason or because of impatience, he leaves that particular space system, and it is called as reneging. Whereas priorities is the term where customers are served before the others. For example, out of these 50 reservation counters, you might have seen that some counters they are reserved for senior citizens, or some counters they are reserved for VIP people like MPs, MLAs. So they get priority over the other customers, right? So this is called as priority type of customers and their behavior. Then the last example is jockeying. Here in this case, imagine that there are only three queues, and in one queue there are 20%, 20 persons. Another queue they are having 70%. Another queue there are again 20%, and all the queues they are getting service. The person who joins any one of the queue later on realize that one or the other queue they are moving fast. So he leave the existing queue and enter into the another queue, and his intention is to get the service as early as possible because he realized that the other queues they are moving fast, or the service rate for the other queue is more than the original one. That's why he shift from one road to another road called as jockey. Then these are the few important points on which the queuing models depend. Number one is length of system. Second one is length of queue. Next one is waiting time in the system and waiting time in the queue. Now, length of system. Length of system means the total number of customers in the system, which includes the number of customers in the queue plus the number of customers who are being served. So that becomes the length of the system. So broadly, we can say that length of system is length of queue. That means the number of customers in the queue plus number of customers who are getting service. That becomes length of system. But if you consider length of queue, it is only related to the total number of customers in the queue who are waiting for the service. They are not actually getting the service, but they are waiting for the service. It is called as length of. Next one is waiting time in the system and waiting time in the queue. It is it has got the same analogy like length of system and length of queue. Waiting time in the system includes the waiting time in the queue plus the actual time he requires for the service. So waiting time in the system is always equal to the service time plus waiting time in the queue. Whereas waiting time in the queue is exclusively a time the customer spends in the queue without getting the service. Then I have already explained you the traffic intensity. It is also called as the utilization factor, and it is an important measure of a simple queue. It indicates, it gives us the the number of arrivals, the number of customers which are present in the queue, or it gives us the queue length. For single server, the traffic intensity is calculated as lambda by mu, that is mean arrival rate divided by mean service rate. For multiple servers, where the number of servers they are equal to C, any constant C, the traffic intensity is equal to lambda divided by number of servers multiplied by mu. Now, depending on the Kendall's notation, the queuing models, broadly the queuing models or waiting line models, they are classified as four models. The first model, you can see that M/M/1 is to infinite oblique first come first serve. This indicates, here M indicates the manner in which the customers are arriving. Here M indicates the manner in which the customers arrive. And I already explained you that the customers arrive in a caution way. Whereas the departure, second M, it indicates the departure of the customer from the system. It follows generally, it follows exponential pattern, some exponential pattern. One is indicating the single server, that is the number of servers which are available in this model. They are only one. That's why we call it as a single server model. And population and the capacity is infinite. Number of servers are infinite. Population may be infinite. It is called as infinite capacity. And the type of discipline which this particular system maintains is first come, first serve discipline. That's why we call this model as a single server, infinite population, first come, first serve.